already, welcome back, boys and girls. It's your main math man, Mr. Shane, coming to you live from Summit Academy. In this video, working on that Unit 7, Lesson number 4. We've been talking about some polynomials and kind of talking about how their zeros work. So in these equations, we've kind of talking about how the degree works, how the number of roots are equal to the degree. If we're given a graph, we talked about the number of changing points and how we can get the degree from that by adding 1 to the changing point. But when you're looking at the equation, what I want you to do is order the following equations from highest degree to lowest degree. So as I'm looking along, I kind of see, well, this is going to be a degree 0, so that should probably be the lowest. Let's say if this is, I see x squared, and another x, so that should be 5. So that's probably going to be the highest. So then I can say that this is going to be 5, this one's 4, 3, 2, and 1. So as I'm looking at this order, again, make sure you're combining all the exponents together. So when I would multiply this out, I would have a degree of 5. When I multiply these out, I have a degree of 4, so on and so forth. Again, be careful when you're looking at the last two. Even though I don't see an exponent on that x, I know it's going to be 1 because I have 1x. However, I have 0 x's, so it's almost like I have a degree or power of 0. Alright, so our objective for this one is going to be describing and identifying what the end behavior of a polynomial is going to be using that degree and orientation. And so what I want you to do is on that paper I gave you, this is going to be your end behavior chart. So let me pull it up for you. So it has some blanks on here. The way I want you to fill it in is like this. So let's say like this. We're going to say, okay, I can split this top table across. I can say I'm talking about my degree is going to be this column. And again, the two choices we have are going to be even and odd. So let me pull this up. So we're going to have our degree in the top column, and so the options for our degree are going to be even, meaning it's an even number, or the highest exponent is even, or the highest exponent is going to be odd. And then the other option is going to be our leading, called our leading coefficient. C-I-E-N-T. What I mean by leading coefficient is that value of A. And the options for that are going to be positive, meaning leading coefficient is positive, or otherwise it's going to be negative. And the way this works is as follows. You're going to kind of use this information to predict what your graph is going to do, or if you're given a graph, you can kind of figure out what your equation is going to have. So the way you can fill it out is like this. So I'm going to start in the top left corner. I'm going to say as x goes to positive or negative infinity, I can say my y values, regardless if it's to the left or to the right, my y values are increasing, so they're heading towards positive infinity. Again, since this is end behavior, it's talking about the far left and far right end of your graph. For the even side, still an even side for our degree, when we have a negative leading coefficient, it's going to be the opposite. So it still has x goes to, let me actually use a different color for this. Let's say, let's do green for this one. Let's say as x goes to still positive or negative infinity, so left and right, and you have a negative leading coefficient, your y values are going to be approaching negative infinity, meaning they're both going down. For top right, when we have odd and positive, we're going to say a couple things. We have as x goes to negative infinity, so x goes to negative infinity, our y values also go to negative infinity. Same thing with as x goes to positive infinity, so does your y values. So we're going to say y goes to positive infinity. And for the last part, when we have odd and negative, they are reversed. So we're going to say as x goes to negative infinity, our y value goes to positive infinity now. So that means as x goes to positive infinity, y goes to negative infinity. So this helps you kind of determine what your graph is going to be or what your equation is going to be depending on what you're given. So as long as you're practicing this, again, I gave you guys 4 spots or 4, spaces for this, so that way you can have this in your binder. All right, and so what does that mean for us? Well, let me hide this again, so let's do this. So when I'm looking at my examples, again, this is exactly what we had. We're saying, okay, some examples would be, so if I look at this even exponent, I'm going to say, well, my even degree, I should say, even degree, because my highest degree is going to be, let's say for this one it's 4, this one is 4, and for this one it's going to be, let's say 6. And so some examples you can have are inside the little boxes here when they match up. So for this x squared as your equation, we're saying the degree is even and the leading coefficient is positive. So it gives you different examples of that, and also kind of shows you what your graph is going to do. So as you move to the left, your y values are increasing. As you move to the right, so are your y values increasing as well. So you can kind of see how this works, and we'll do more examples with that. So now on the next part, it says the end behavior of this polynomial is as you move to the left, your y values increase. As you move to the right, your y values increase. And it says we read it as when x approaches negative infinity, y approaches positive infinity, and when x approaches positive infinity, y approaches positive infinity. So this is going to say this is a 4th degree polynomial with a leading coefficient of a being positive. Again, we know this is a 4th degree because if we count the changing points, we have 1, 2, 3 changing points, 3 changing points or points of inflection, which means we have our degree. Our degree equals 4. All right. On the next part, what about this one? It says, what is the degree of this polynomial? Well, let's count those changing points again. So let's say like this. You're going to count those changing points or those turns. I have 1, 2, 3, 4. So our changing points, we have 4. And so that means our degree is going to be the changing points plus 1. So our degree is going to be equal to 5 for this one. So you're going to make sure you take your time as you're doing that. Find your number of changing points, find your degree, and now we can say, well, this narrows down what our equation should be because we know that our highest exponent is going to be 5. That means our polynomial, or that degree, is going to be odd. So since 5 is odd, we know our degree is odd. So then what about the leading coefficient? Is it going to be positive or negative? So let's go, let me actually pull up our chart again. So let's pull up the chart again. We said our leading coefficient is positive.
Just a reminder, attendance in the spreadsheet.
So as we're looking at our table here, again, we're kind of saying, well, is it going to be, we know it's going to be odd for this one. So we said, well, it has to be, the leading coefficient has to be positive or it has to be negative. So now let's look back at our graph. let's say, okay, as we are, let's pull it up like this, as we're moving to the left, so let me write it like this. As we are moving to the left, meaning as x goes to negative infinity, our y values also go to negative infinity because they go down. And as we move to the right, our y values increase. So that's going to be that positive leading coefficient, because we could say it like this. So since x, or let's say it start off first. So since our degree is odd, and let's say and as x approaches negative infinity, y approaches. So let's do it like this. So since our degree is odd, x approaches negative infinity, y approaches negative infinity. And as x approaches positive, say positive infinity, we know that y approaches positive infinity. So since we have these things, we know our graph matches up. All right, so again, use that table and use your picture to kind of figure out what your leading coefficient would be for this equation or for this polynomial. All right, so it says, what is the end behavior? So it says using the math, or try writing it using those symbols, so you can copy and paste it in. So let's try going back and saying what it's going to be. So let's say, let's write it like this. So we said as x goes to positive infinity, so does y. As that y goes to negative infinity, so does y. So let's do it like this. So you can highlight, let's do copy. So let's do x, let's do like this. Let's say x, paste. So let's say as x goes to positive infinity, y goes to positive infinity as well. So paste and positive. And so let's say, I actually cut and paste that in there. It'll let me. And let me try for the other one. Let's do negative. Let's do negative infinity. So I have both of those. As x goes to positive, so does y, and as x goes to negative, so does y. So try using those to type those in. Another way you can do it is if you have that little math tool, you can say, I think this works. If I type in backslash and infinity, so INFINIT, and then as soon as I hit Y, it should change to the symbol. Yeah. So if you hit the little math symbol, or type the math button and type in the word infinity, it should come up. I wonder if it says approaches. No. Okay. I was just curious if that worked. That's okay. So we have what we need for now. All right, so what about this one? What is going to be our degree? Alright, so first we're going to count our number of changing points. A way that we can do that is like this. It's a little trickier on this one because if you look at this point, we're going to actually count that as 2 changing points. So count, let me write that, count as 2 changing points. So that means we have 1, 2, 3, 4, 5 changing points. So that since we have 5 changing points, that means our degree is going to be equal to 6. So go make sure you type in 6 and we are good. So that means our polynomial is going to be even. And so now we can use that to figure out what our leading coefficient is. And I can say, well, looking at our chart and looking at our picture, as we go, let's say, as we go to the left or to the right, our y values are going down because they're pointing down as they approach negative or positive infinity. So that means our leading coefficient is going to be negative. So we can say as x approaches positive or negative infinity, y approaches negative infinity, which matches up with what we have in our little table. So now let's try typing in so that way we can have our symbols in here. So copy what we have. So we have x goes to, let's say, negative infinity. So does y. So let's say y goes to negative infinity. And then we could say, same kind of idea, let's have x goes to positive infinity, y goes to still negative infinity. Just make sure you can separate it like that, that way you can see both of those together. So now for the last part, try it out on your own. So write the end behavior in the box below, include the include the degree, and if the leading coefficient is negative or positive. So again, count the changing points, find out where your degree is, and then using the graph given, find out what your leading coefficient is, whether it's negative or positive, and make sure you can type it in the space given. Be sure to pause or rewind and replay as needed, ask questions, and as always, super slam that subscribe button.